Thanks for Lina. Can everyone see my screen?
Yes.
Okay. Ladies and gentlemen, it's my pleasure to share with you on the topic of intent-driven experience cognition network. As we all know, intent is a popular concept at present. In telecommunication, we have some operation and maintenance challenges. From the second generation communication network to the fifth generation communication network area, our communication network is growing more complicated, such as 5 network types and 13 frequency bands. Meanwhile, our operation and maintenance interface is always an engineer interface. That means it is very friendly, maybe friendly for engineer, but very hard for ordinary people to use. If you want to use it very well, you must spend a lot of time to learn. The other challenges is the low efficiency. According to Garnet data, 75% organizations still manage their network manually. In the 5th generation communication network, we need quickly and automatically manage our network. The manual or script-based operation and maintenance, that efficiency cannot meet the requirement anymore. Therefore, we have some requirements such as differentiation and cost reduction. We need the network to provide differentiated scenario service to cover many kinds of service. Also, the network can provide more efficient assurance, reduce manpower, and further reduce OPEX. To sum up, the intent concept we introduce to tackle the challenges and meet our requirement. Now, let's take a look at the value of the intent-based telecommunication network. We think the intent-based telecommunication network will bring us some values as follows. First, accuracy. We right now bring AI in analysis, verification, and exclusion so that it can be smarter with learning and training. It can reduce the risk of errors and provide more accurate analysis results. Second, agility. The network can be rapidly adjusted with few manual intervention. Third, cost reduction. Network performance can be assured with few operation and maintenance manpower. That will finally reduce operation and maintenance cost. The industry's conception of intent is also a general process. From the concept proposed by David Narrowed in 2015 to Garner's definition in 2017, understanding of intent is becoming clear. Now, we believe that the intent will be the right answer for our complicated network. Intent-driven network can implement the following feature to maintain operation efficiency and reduce network risk. First, verification. We verify the declarative intent target before being applied to the network with geometric check and the semantic check of the context. Second, instant rollback. Once a problem occurred on the network, appropriate intent object with a version is applied to return the network to a normal state before. Third, the function scope control. When a new intent is implemented, the scope should be controlled through a complete predefined policy. Last, intent-based assurance. Even when an interruption or maybe equipment fault occurred, the system can reconfigure other network element in the network, or can use different mechanisms to achieve the same target. Now, let's move on to the pain point of network service assurance. In the daily network service assurance scenario, we usually have 3 phases, including a before assurance, under assurance, and after assurance. In these phases, we need to run the many actions such as adjusting network parameters, assurance monitoring, troubleshooting, automatic closed-loop exclusion, and effect evaluation. This traditional assurance mode brings us many pain points, such as unfriendly main machine interface, later response, inflexible scheduling, and maybe cannot be continually assured. In the intent-driven experience condition network, we can identify intents, match different level of assurance capability, and provide differentiated network service quality assurance. With differentiation service, including scheduling, priority, policy, and algorithms, we define 3 grading assurance capability to meet the differentiate network service requirement. Here is the system flowed chart of experience condition network we planned in China Mobile Fujian project. First, a service logic input. The user input the service logic in natural language, including the area, the application, and time, and the assurance level. The second, we see the intent translation. The system detects whether the intent is input correct, then guide the user to input the intent, and the system translates the user's intent to machine instructions. Third, pre-evaluation and conflict detection. The system checks whether the service assurance intent is visible, whether it conflicts with other service, and provide modification suggestion. The fourth, intent exclusion. The system ensured user application experience with differentiated scheduling based on 5 QI, slide ID, and service parameter policy. The fifth, intent assurance. The system rapidly evaluates and continually monitor the effect of the intent assurance. If users' requirements cannot be met, then an alarm is raised. Here have 2 examples. You can see it in China Mobile Fujian project. First, maybe we can command the system like this. We check video interruption in the Gulo district. Go optimizer. Then we can see the system will feedback us like this. Okay, all the node B in the Gulo area of Fuzhou start level 3 assurance of the WeChat video service immediately. Then another case you can see, maybe we command the system like this. The Fuzhou hospital will carry out nuclear access testing tomorrow. Let's assure it. Then the system will feedback us like this. Okay, the level 1 assurance for the QR scaling service started within some error on some street in Gulo district, Fuzhou city. Okay, just above is 2 examples. The experience condition network will bring us the value as followed. Well, firstly, is the friendly interaction. We only need to tell the network management objective and constraints, but we didn't need to know the implementation method. Second, the faster response. With the mini-level response and the evaluation, the millisecond level, the service identification and assurance policy, we can improve the assurance efficiency by more than 95%. The third is extreme performance. In the congested scenario, the service UV performance is improved. The maximum 50% delay is reduced, and the throughput is increased by 100%. Last is the continuous assurance. The system provides flexible scheduling to assure the services in the full time. Okay, finally, let's look at the further prospects. We have planned the 3 phases for the intent-driven network. In the 2022, we will be in phase 1. In this phase, we will support intent-based experience assurance for a RAN scenario with JTE. In the 2023, we will go to phase 2. In this phase, we will have a expression for planning and development and the maintenance, optimization and operation. We will build an end-to-end process, integration in RAN, core network, and the transmission. After 2023, we will go to phase 3. We will collaborate with more vendors to try to contribute to the standardization. And finally, we will achieve the full automation based on the intent. Okay, that's all. Thank you for listening.